One more example. Example number 5. Example 5. A line drawn from the midpoint of one side of a triangle parallel to another side bisect the third side. Yes, I am drawing a triangle ABC. DE is drawn parallel to BC. Now given that this you have to prove, okay? Proof. Given that in triangle ABC, D is the midpoint on AB. See, D is the midpoint on AB because a line drawn from the midpoint of one side. This is the midpoint and this is one side. Parallel to this side. This line is parallel to this side. Bisect the other side. This is other side. Which is this line is bisecting the other side AC. That is what you have to prove. Now point on AB and DE is drawn parallel to BC meeting AC at E. To prove AE is equal to EC. AE is equal to EC. Proof. In triangle ABC, DE parallel to BC. Therefore, AD by BD is equal to AE by CE by Thales theorem. But D is midpoint on AB. Therefore, AD is equal to BD. This implies AD by, see this BD, this I am taking again, this is AD is equal to BD I got. In place of BD I am writing AD is equal to, because AD and BD are equal, AD and BD are equal, D is the midpoint. So in place of BD I have written AD is equal to AE by CE. These two cancel one by one. Now cross multiply, AE is equal to CE. This is proved. Therefore E bisect AC. Proved. Example number 6. If the diagonal of a quadrilateral of a quadrilateral divides each other proportionally, then it is a trapezium. So I am drawing a quadrilateral drawing a quadrilateral, and the diagonals I am drawing at these two intersect at E, and A, B, C, D is a trapezium. Sorry, diagonal. Sorry, what is this? Quadrilateral. It is a quadrilateral. We have to prove that it is a trapezium. It is a quadrilateral. We have to prove that ABCD is a trapezium. So trapezium. One of the property of trapezium is a pair of opposite sides are parallel. So this opposite side must be parallel. If AB parallel to CD, then we can conclude that this is a trapezium. Then see, ABCD is a quadrilateral whose diagonals AC and BD intersects at E such that DE by EB is equal to CE by EA. That is, they are saying this divide each other in proportion. The diagonals are dividing each other in equal proportion. So DE by BE is equal to CE by EA. This is given to us. To prove ABCD is a trapezium. That is, you have to prove that CD parallel to AB. That is our target. Construction. I'm drawing construction one line. This is FE. FE drawn parallel to AB. Proof. See. In triangle ABD, this triangle, in triangle ABD, EA parallel to AB, therefore DF by AF is equal to DE by EB is equal to DE by EB. This is by Thales property, Thales theorem. This is by Thales theorem. I am marking it 1. But what happened here is, what is given to us is DE by EF, DE by EB is equal to CE by EA. This is given to us. This is 2. From 1 and 2, what you are getting, see, these and these are equal. When these two are equal, these two will be equal. From 1 and 2 to DF by AF is equal to CE by EA. This means what, say, if DF, which one? DF by AF is equal to CE by EA. That means EF parallel to AB, EF parallel to DC, EF parallel to DC. In this triangle, you see DF by AF is equal to CE by EA. So EF parallel to CD. But this is we are getting EF parallel to CD. EF parallel to CD. But EF parallel to AB by construction, we have taken it. So from these two, what we are getting, EF and EF are equal, then AB is parallel to, therefore AB parallel to CD. This is parallel to this is also parallel to AB. These two are same, then these two are parallel. When you find that AB parallel to CD, so AB is parallel to CD. When these two sides are parallel in a quadrilateral ABCD, AB is parallel to CD, therefore this became a trapezium. Therefore, hence ABCD is a trapezium. This is proved.